thing to say is that when people think aerospace, they think one aircraft. They think basically the A320. That's what people think of. Aerospace is similar to when you say ground mobility. I mean, a scooter is the same thing as a long haul truck. Those are ground mobility, but don't compare one to the other. So in aerospace, the same thing. You have the light spot aircraft, which are the aircraft that you can take and just fly around with your friends. Then you go into the smaller aircraft, then the bigger aircraft, and you end up with the A380, something that can actually fit 700 people inside and do, transatlantic flights. So those are very different scales and very different ways of working, and therefore the solution also is going to be different. And yeah, so in that respect, each of them will have different solutions, right? So,
but there is another company doing the same,
yeah. So I would say there's small companies. There's already aircraft like light sport aircraft which are electric. There's only one pipistrel which already has a certified version. You can actually buy it and fly electric. There's gliders and small aircraft that already have something because they're easier to work with, and also regulations are small because it's your own risk. As far as we know, in the market we're in, there's 2 or 3 companies trying to think about these things. There's companies working on electrification of all this. Some are working more into the hydrogen, more into the batteries, more of a combination. So there's different actors in the field, and then of course in the higher field, then there's less and companies. Some companies trying to go to the regional flights, 70 passengers, 1,000 miles, things like this. So yeah, there's different companies trying to work on. Most of them are startups. Some of them are big companies trying to work out on how to make these things. But it's complex enough that there's no competition right now. Everybody needs to just stand together and make it.
No, because I think it's the same thing that happened with the electric cars. Electric cars, there was one company like Tesla there were previous companies. It's not that Tesla invented that, but there were a moment that Tesla and many other companies start to create electric cars. And at this point is when, everyone accepted that. You can drive with an electric car. And I think that the same thing could happen with airplanes. It's not like, okay, I flew in an electric airplane. The first time, maybe you think twice. Okay, maybe, I don't know, because you have no idea. A person like me is not like a person like you, Ignacio. Yeah. And you don't know what could happen. But as soon as you see more and more and more, you understand. This is the same that when you are in a Rolls Royce, in an airplane, and the engine is Rolls Royce. Because at the end, Rolls Royce, how is doing Rolls Royce engine, engines for an airplane. So at the end, it's these kind of things that when you are used to that, you say, okay, it's normal.
Yeah, definitely. That's why we want to go to market soon. I mean, aerospace takes years to develop, and a full aircraft takes a decade to do, and that would be being quick. Usually the other programs take 15, 20 years because there's so many things to do. That's for a brand new aircraft. So yeah, there's definitely need to work on. And in fact, one thing is to mention is, we already mentioned this when we discussed, but aircraft are there for a long, long time. If you try to get a new aircraft today from Boeing or from Airbus, you can just pay the 100 million you need to pay for it. You will get it in maybe 3-4 years, or I think maybe now 6 or 7. That's the backlog they have. And then it will operate for 40 to 50 years. Okay. So an aircraft bought today will be there in 60 years, still flying. So it's different from cars in the sense that a car, you buy it now, and if you're lucky, you sell it in 15 years. But that's, when you have got everything you can from it. People usually buy new cars every 5 years, every 4 years. Aerospace.
Are you saying we cannot expect a major shift in aerospace industry in the next 50 years? And what you are trying to do is to offer something new that people can upgrade the existing aircraft with whatever technology you are developing to make this future come faster?
Yeah, in a sense, we're saying that, but also at the same time, we're pragmatic enough to know that we're not going to, we cannot solve all the problems. So, in our opinion, the solution to aerospace is going to be a mixture of technologies. So, for the small aircraft, you're able to go with batteries for short haul flights at the beginning, and then you will need to start putting hydrogen inside in order to make it run longer. And then if you go to the bigger aircraft, the more recent research shows that it's better to actually burn hydrogen in order to make it viable. In the meantime, there's works like the sustainable aviation fuel, which is synthetic fuels or biofuels, which could also be part of the solution by taking back the carbon dioxide and putting it back into the system, either synthetically or with biomass. So there's, in the end, we want to, in 2 years, we're not going to be able to fly you from Paris to New York. That's one thing that's for sure. But yes, we'll be able to start nibbling at that thing and start getting some customers to actually fly electric. Maybe open up some new routes, like flying from in between the Balearic Islands and just from Formentera to Mallorca and just fly electric. Because right now there's nothing; you just need to take a ferry. So yeah, we definitely think that we can actually change some aircraft to make it electric. But completely honestly, we will not be able to give you a Paris to New York in the next 2-3 years, or even the next 10 years.
And one question, Nathy, because one of the main factors, for example, I'm talking about the car because it's the only thing that I know a bit, and I am not a car driver either, so it's imagine myself. So, but I know that when you have these kind of explosion cars, the all typical cars, with not non-electric cars, it's a car that you can have for 20, 30, 40 years, it's more or less the same example that you were telling to me with the airplanes. No? You have a car for 50 years. And even if you go to places like, for example, where the family of my wife is in Venezuela or Cuba, you have cars for even 60 or 70 years. It's not a problem. But the question is, when you have electric car these days, the one that it was created 7 years ago is not valid anymore. You cannot use this car because of the way that the car are created, not because of the engine, it's because of the battery and because of the companies. They put all together in one piece, and it's the way that they do that, no? Because it's part of the business. I put all the engine and the batteries all together in one piece, and if you open this piece, then you break the rules, and it's not valid. Then as soon as you want something like that, I need to replace everything and put something. Imagine a car of 30K, you need to pay 20K for the replacement of the battery. So then I
So
want to end that.
I'm not sure I agree with that so much. So the first thing is, the cars that you see running for 60 years, you can change everything because they were so simple that people just they broke on in the road, and you actually change things yourself.
Yeah.
Now try to do that with
this.
a new car. I mean, try to get a Mercedes and try to just in the middle of the street and any car that you can think of, open it up and change something. You can't. There's too much electronics, and electronics are not as simple to change as mechanical things. Electric cars, data shows for the moment that electric motors can last longer than a combustion engine. Batteries do degrade, but they don't degrade as fast as people feared, and therefore, electric car can run for years. It will have less range, but it will still operate, and you can always change the batteries. The reason the battery is so expensive is because the battery has lots of raw material. It's heavy. It's a big thing of the car. But you can definitely change the battery. And in fact, if you're knowledgeable enough, people have changed their own batteries and opened the battery of a Tesla and replace cells. You can actually do it. But I wouldn't recommend it to people who are not experts at that. But the same thing, I wouldn't recommend people to start changing things in a combustion engine of their car if they want it to run. I mean, it's
But
just that
my question was, how are you going to try to do in an airplane to be able to make this airplane valid for 20, 30, 40 years? What is the plan of that?
One thing that you may not be aware of is that aircraft, they do have very strict maintenance intervals in order to be safe. We'll come back to the safety afterwards, I think. And therefore, every certain number of hours, you need to take the aircraft and do an inspection. In fact, you do an inspection every single flight. Then depending on the aircraft, maybe every 1,000 hours, which is maybe a month, you need to take the aircraft and start checking everything inside it, and even replacing some parts. That's called the A check. Then you go to the B check, which is done depending on the aircraft, maybe 5,000 hours, 6,000 hours, and you start replacing big components. And at some point, you actually replace the whole aircraft, take all the pieces off, and put it back on, and you make it new. And that is true for engines also. The engines, you basically take them off. At some point, you open up completely, take all the little pieces inside. The ones that are serviceable, you clean them up, put them back on. The ones that are not serviceable, you send them back, and you get new ones. So aircraft are always being updated and replaced. It's just that you don't see it as a customer, and we don't do it with cars because we don't want to go to the system all the time. But you're changing filters. But in the aircraft, you actually at some point you change the whole thing. And as soon as
so it's not that you pay 100 million, it's that you pay 100 million plus. Later on, you need to continuously.
Yeah, in fact,
say the pieces.
Yeah, I mean, if you take one of the big aircraft, the aircraft costs maybe 100 million. I don't know exactly the price right now for an Airbus or a Boeing, but it's in that range. 1/3 of it is the engines. So you're paying 30 million just for the engines, and then you're probably paying I don't know how many million per year. So the engine manufacturers actually have that engine working for you.
It is something you have to take into consideration in your current position. Like you propose products, solutions to the existing aircraft, to the companies, and you have to think like you will need to make maintenance once in certain months, and this is what we do, and this is what we check for. It's like you are creating the plans, what needs to be checked, because why? Because you know what can break in
Yeah.
those
So
tools.
and
Or
this is where, for instance, AI will come in handy in the future. But yeah, basically, you already know combustion engine aircraft. You already know the intervals. You know that how much you spend every month on maintenance and how often you need to change the engine and change things. What the cost of that is. What we offer our customers is we tell them your aircraft it will cost you this much to retrofit, and then you will get some benefits because first of all you only need to replace the batteries every this often. The motor will be this much this often, so you need to replace things which are going to be less often than the other ones. So you need to integrate that cost saying you need to buy a new battery every 2 years and then replace it. The engine will last for 5 years, and then we do a maintenance into it. So there's things like this where
Okay.
you can actually work on, and in the end it comes up to same thing as a logistics company do. I mean, when you go to a company, you go to trucks, they actually look at the exact maintenance thing they have in order to know how much the system costs overall, not just the purchasing cost, but the cost of ownership. Aircraft do this all the time.
and
It's
how do you
normal.
set these intervals, like based on what? Based on like certain materials can only handle so much pressure at a current
Yeah.
on this
So
period, and you know this by testing. You are doing tests on that, and then you make notes like this. Okay, this will break in 5 years, but I will tell my customers to change it in 2, just in
yeah,
case.
and that's where rules come in and where the industry has moved on. So the old way of working, old way, and it's still valid for some systems, is if you want to justify that your system will last for 1,000 hours, you basically test 3-4 times that, and you show that in 4,000 hours it didn't break. Therefore, I'm happy with 1,000 hours. I'm pretty sure it will not break. So every 1,000 hours you change your system, even though it has 2,000 hours of potential life. But in order to be safe, because if the thing is critical and could create an accident, the choice has been made to prefer safety over expenditure in this case. So some things, the old way of working was, you test up to a certain limit, and then you divide that limit by a margin, a big margin, and then you say every this much I replace the system, and I don't care how it is, I replace it. Now more and more, there's with all the power of data analytics, there's predictive maintenance coming in, where if you're able to monitor your system and understand it, you're able to see degradation and say, okay, this system is still running fine, I can wait for the replacement, and you do an unconditioned maintenance, which is much more efficient than just saying, this computer is working perfectly, but it's 1 year old, I'm going to throw it away. You're more monitoring, and this is one of the places where in the industry is actually working a lot. There's even some works on getting real-time data from the aircraft in order to do a big lake of information in order to understand the way they work. To be able to say, okay, when you land in 3 months, in 3 weeks, you actually need to change this instead of being set in stone. And this is coming. Electrification has the benefit that electric systems, you monitor everything because of the way they work. You have lots of data. In normal systems, you need to put sensors in. In electric systems, getting a voltage is easy. You actually do it in order to operate the system, so you already have it. So there's ways where electrification makes it simpler to actually follow that up and do from predictive maintenance. But then that's where we actually need all the power of data analytics and to help us with that place. But there's tons of money put into that because it's a big market. In fact, I think MRO companies, so maintenance and repair organization companies, probably make more money than companies like Airbus or Boeing. There's more money to be done in same thing for cars. I mean, I think garages make more money than Volkswagen or Mercedes because of maintenance of cars. Maintenance is something that seems small, but it's actually a huge market and it's a huge element.